Hey everyone, in today's video we are going to go through the process of creating a roof and really understanding a type of roof workflow that we can use in Blender. The workflow we'll be using can be applied to many other types of roofs, and it will ensure we get clean geometry and the ability to continue modifying our asset at a later stage through a fairly non-destructive method. The example we'll be using is a Japanese styled roof. Just a few disclaimers before we get into anything. This video will only show you how to create the core roof mesh. So we will not be designing those shapes on the corners of the roof that you see in most Japanese roof designs. We are only focusing on the actual tiling of the roof. And we are not going to cover textures and materials. Two reasons for that. One, texture and material creation in this particular case will require diving into another piece of software, which would not be fair on a lot of people who just use Blender. And secondly, texture and material creation is a whole other topic of its own. It really isn't that comparable to 3D modeling, no matter what some people tell you. But I will do tutorials on material creation in the future, so don't fret. I might show an example of applying some materials to our roof at the end of the video, but it won't be an in-depth explanation. But if you want to texture your roof, there are many websites online where you can download textures to do this. Or if you are already knowledgeable with texture creation, then you can create your own, either using Photoshop, Substance Design, or even using texture baking methods. I just want to make the point that this video covers general roof workflow, and we are happening to use a Japanese styled roof as the example. So let's just keep things simple, and if people want to see me take this design process further, then I can. So, before you create any 3D model, it is good to understand what you are actually creating. So here is my reference image. So theory is a vital part of the process. You should have reference images and also some background knowledge of the materials and the general design of the asset you are trying to build. So in this case, people will just call this a Japanese styled roof because, well, that's the easiest way to explain it. But it isn't called that. This particular roof style is called a Kawara Roof, and I really hope I'm pronouncing that correctly. So if you were to type in Kawara Roof into Google, you will find images and search results specific to what you are trying to create. As I said before, this workflow can be used to create many types of roofs, and you are not just limited to a Kawara Roof style. You can do like a Roman style, for example, or any other curved roof styles using this workflow. So workflow is an extremely important part of 3D design because if you create a nice modular and non-destructive system for the asset you are designing, then you can use the same system to create other similar assets. So just keep that in mind. Another thing I want to state before we get started, this video is not aimed at beginners. We are going to cover some higher level concepts of 3D modeling, and although I will make it easy to follow along, it's really meant more for intermediate to advanced users of Blender. So I strongly recommend you follow my Blender beginner tutorial series before you start watching any video like this one. Right, so let's get started. First of all, let's delete everything on our scene. Click A to select everything and then delete it. And now let's create a cylinder. Rotate it on the x-axis by 90 degrees. And do not scale the cylinder, just keep it as it is. Now let's create an array modifier for it. And put 2 in the x-axis. Now let's create a plane that sits in the middle of these cylinders. With the plane created, move it on the x-axis and type 2 to bring it this way by 2 meters. And now we'll just move it uniformly between the cylinders. Now let's optimize the geometry a bit. For the cylinders, delete the faces at the bottom here, below where the plane connects. So to do this easily, let's just go into front orthographic view and also go into wireframe mode with face select on. And let's just grab our bottom faces here. back into solid mode, and let's also grab the bottom face, the back face around here. Delete the faces, and there we go. Lastly here, we want to just raise the edges of our plane here. If you look at our reference image, you will see that the ends are a bit more raised. With the plane selected, create 6 loop cuts. 1, 2, 3, 4, 5, 6. And then just confirm the selection. And then select the edges here on the corners. And with proportional editing mode turned on, as well as snapping mode with edge snapping enabled, we basically want to bring it up to the next edge here. But we want to make sure that the plane in the middle here remains flat. So let's go into front orthographic view. I'm just going to bring down the proportional editing circle. So something like this. And we just want to snap it just to the next edge. Like that. It's not completely uniform with the edge, but the snapping mode just gives us a bit more of a uniform placement because we want it roughly around that area anyway. Right, now I'm going to select the end faces here and add a bevel with Control and B. And I'm just going to scroll up on the mouse wheel 4 times. 1, 2, 3, 4. And it's just going to give us a nice smooth ridge. So let's do that. And let's also dissolve these edges here, as we don't really need them. You should now have a nice curving shape to the plane. Before we continue, I just want to look at our reference image again. You can also see that there is a cylindrical shape that runs on the seams here between the plane and the cylinder tiling. So let's create this. I find that the easiest way to do this is to select the edges right on the ends here and then separate them into their own mesh. So as you can see, the lines here, let's just turn off the snapping mode. The lines here are their own separate mesh now. And now let's convert these lines into curves. And now that they're curves, let's come down to the object data properties here. Under geometry, change the depth to 0.01. Now let's convert this new shape back to a mesh. And what we can do now is come to the edges here. Alt-click the front part and then click F just to fill in the gaps here. Right, this is where the magic comes in. Now let's join all of these shapes together. And now let's create an array. And set the count to 10. Although you can do whatever number you want. It just depends how long you want the roof to be. But this is fine. And also remember to turn on merge. And let's create another array. But this time I want to offset it by 1 on the y-axis. And then 0 out the x-axis. And again, let's set the count to 10. So you can probably understand how this workflow is starting to get us a roof shape. Again, let's turn on the merge. But if we go back to our reference image, you can see that there is actually a bit of an offset for each tile here. Well, we can actually easily mimic this in Blender thanks to our array modifiers here. Come to the z-axis of our second array that we created and put in 0.03. and that will create the offset that we want. For the plane tiles here, we are just going to select the innermost edges, just here, not these end parts, and we're just going to drag them down a little bit. Let's turn off proportional editing first. Just drag them down a little bit. So coming back to our reference image here, you will see that the tiles in the middle have some thickness. So let's grab all of the edges on the front and extrude them down on the Z-axis until the gaps get filled, just over here. Another thing I want to do is mark the edge of our flat plane here as sharp. So Alt click and then mark as sharp. And then make a loop cut and just slide it to the end. This is basically going to help us with the shading calculations later on when we start to smooth out the roof at the end of the video. Because if we didn't have any sharp edges, the shading will just think that everything is rounded, which is not the case at all. Let's do the same trick for the main curved tiles up here. So Alt click these, mark as sharp, loop cut, and bring it in. I just want to line it up with this loop cut here. Something like that. Next, I'm going to change around the geometry for our front end cap here. We need to do this because if we were to apply the array modifiers now, we are going to have all of these large circles appearing all over the place. So there are two parts to this. First, in edit mode and face select, let's inset this face with I. Second, in front orthographic view, drag a selection box over the middle part here. So we want to grab all of the bottom half faces of this circle, which will also grab the larger circle in the middle here, which is what we want, and now delete those faces. So what this has done is it still retains our geometry, but only in the places where we need it. So after we apply the array modifiers, we can just rebuild the front end caps here, and we won't have to worry about it being duplicated across. Next, I'm just going to sync up these small cylindrical shapes with each other. And I also want to do the same with the edges of our plane tiling, because at the moment you can see they're a bit offset. So let's select the edges of our middle tiling here. So select and select, turn on proportional editing mode, and then rotate on the x-axis just until it starts to line up. But that's basically what you want. So it's kind of moved up the tiling a little bit here, and it's also linked up these cylindrical shapes. So the roof is coming along very nicely now. The next part requires us to apply our array modifiers. So make sure that you are happy with the length and the height of your roof. It would be a good idea to make a backup save file now so that you can always revert back if you need to. So I'm just going to do that. I'll come to save as, and I'll just call this Kawara Roof 2. Before we apply the array modifiers though, we should make some vertex groups that we can easily reference geometry later on if we need to. So come to the vertex groups section here, go into edit mode, and let's just create some vertex groups. I want to create one for the caps here. We'll just call it caps, assign, and I always like to deselect and then select again just to make sure that it's registered correctly. Then deselect everything, and then let's do the same for our cylinders here. And let's do cylinders, assign, deselect, select. Let's do the same for our main tiling here. And you can name these vertex groups whatever you want. There's no hard and fast rule for it. And now let's select the middle tiling here. and we'll just create a vertex group for this. So I'll just call it middle tiling front or something like that. I'm just going to save that. So, confused as to why we bothered making these vertex groups? Let me show you how they come in handy. Right, let's apply our array modifiers. So what if now you want to select all of the front tiling parts here? Are you just going to come through and do Alt, and then Alt again, etc. across the entire roof? Well, no, you're not. So this is where vertex groups are useful. So the thing is, array modifiers remember vertex groups and will apply the duplicate geometry from the array to our vertex groups. So for example, if I come to the vertex groups and if I was to click select on the middle tiling front, you can see it's actually selected, well, all of it across the entire roof. And if you want to make any changes to it now, turn off proportional editing mode, and there you go. So this is very handy. With that out of the way, let's move on to the next step, which is constructing the front end caps here. So first, let's create a circle. And do not scale it. We just want to line it up with the front tiling here. So I'm going to rotate on the x-axis by 90 degrees. Just bring it to the front here on the y-axis. Somewhere around there. And then in edit mode, vertex select mode, I'm just going to come into my front view, F to fill in the face. Actually, no, we want top orthographic view for this. And now extrude the faces outwards just a little bit. Something like that. Before we continue modifying this, I'm just going to hide this circle quickly. Of course, we don't need these caps here for our front parts. So let's just go through and select these. Slightly tedious this part, but there's no other way to do it. And this just keeps our geometry as clean as possible. Let's just delete those faces now. And then let's bring back our circle. Right, and for these faces up here, which we extruded, let's select them all and then extrude out a little bit along the normals. Just like that. And now with the front cap selected here, we're just going to extrude the face inwards a bit. Like that. Now let's apply an array modifier, just so we can apply it to all the other parts here. Put in the same count that we did before for our arrays, and for this we're going to want to use a constant offset, as the relative offset won't help us this time around. From doing this before, I think a good value was about 4.01 meters in the not the z-axis. The x-axis. Yeah, that works. So yeah, 4.01 meters in the x-axis will line everything up just fine. Now apply the array modifier. We also need to add the front caps for the middle tiling here, as you can see in our reference image, this part here. So let's go into edit mode, select the bottom edges of the front part of our middle tiling here and separate it into its own mesh. We will add this to an array in a moment. And now, whilst in orthographic view, I'm just going to edit mode as well and select everything with A. Let's start extruding this down on the z-axis. But we also need to make sure that we're conforming to the shape with the cylinders. So when we extrude again, just scale on the x-axis just to make it line up. Could be a little bit tedious, but the results will be worth it. And that looks alright. And now with face select mode on, select the bottom and the top faces and extrude them out a little bit, but not too much. We want the front caps here for our main tiling to stick out more than these parts. Let's also mark the edges of the extrusion as sharp. So what I mean is these parts here. Again, same reason as before. Mark sharp. This is all for the shading calculation. Just bring the loop cuts to the end. Something like that. Now let's add an array to that. Array 10, and same as before, we did 4.01. Oh, not in the relative offset though. Constant offset 4.01. There we go. Now apply the array modifier. I also want to delete the flat tiling at the end of the roof here so that both ends are symmetrical. So let's select each of these tiles with L, and then if we come in a bit more, this cylindrical detail here, let's just click L on that, and then just delete the faces. And actually we want to do the same here, so let's just click L. Yeah, so we should have actually done that count as 9, not 10. That's fine, easily fixed. We are now going to start adding the main curvature to our roof that you see with a lot of old Japanese architecture. We are going to do this using a lattice and a lattice modifier. But first I want to set the origin of our roof here to the center of mass surface, so that our small orange dot, which you can probably see here, probably very hard to make out, it will just move it into the middle of our roof, so that when we create the lattice, we'll be able to scale it uniformly with our roof. It's not mandatory, but it just makes everything a bit more symmetrical. So origin to center of mass surface, and then do Shift and S, cursor to active, there we go. And now let's create our lattice. On the creation menu, come here, lattice, and now let's scale that up. Just make it just over the bounds. So now I'm going to scale and move the lattice around so that it fits nicely outside of the bounds of the roof. Now let's increase the resolution of the lattice. Come to the lattice object data properties here and change the U resolution to 5 and the V resolution to 4. This just gives us some more control points for our deforming of the roof, because that's what the lattice is going to be used for, and you'll see how that works in a moment. Now let's select the roof. Under the modifiers panel, let's apply a lattice modifier, and then select our lattice as the object. So just to show you quickly, if I select the lattice and go into edit mode, if I was to now grab a vertex and move it, you can see it takes the roof along with it. And this is how we're going to get our curvature. But first, let's just select everything and rotate it on the x-axis by 30, just so we have the roof on an angle which we actually want. If you want it to be steeper, then do a different angle. And now, let's start deforming. Come into the lattice here, edit mode. And first of all, And you can do this in any way you like, but my method is grab the middle vertices here and then move them down a little bit. Another thing I forgot, for the roof and the front tiling we did here, Control J, we want to join that before we start doing anything. And the same with a circle, Control J. We want all of this to be joined, otherwise the lattice is going to move the roof away from the separate meshes here. So back to Lattice modifier, just check that all the middle vertices are selected. Now let's move this down just a little bit. So you can now see, now that we've joined everything together, it's all deforming nicely with each other. Now I'm going to select the most middle vertices and move them down very slightly. Now I'll grab the second to top horizontal lines here and move them down very slightly. And grab the second to bottom horizontal lines here. Again, just making sure I've selected everything at the bottom here. Move them down very slightly. Grab the top vertices here. And move them up just a little bit. And then grab the edges of the lattice here. And then shift drag. And then move them up just a little bit. Probably a little bit more than that actually. And then what I'm going to do is I'm just going to grab the front vertices of the lattice here, and I'm just going to come into right orthographic view for this. But what we want to do is we want to rotate them on the x-axis so that the end caps face a bit more forward. But we don't want to do it too much because we don't want to deform the tiling here to an extreme level. So let's just rotate gently. Something like that. So that they're facing a bit more forward. Now let's hide our lattice with H and see what everything looks like. So I think that looks pretty good. And again, you can do whatever shape you want here. You could make it a lot more steeper here, or to be honest, if you didn't want any curvature, you could just not even use the lattice. It's whatever you are going for. And if you feel like anything looks too sharp, then you can come back into the lattice and just adjust the resolution. So like if I were to change this to 8, you can see it just gets a lot smoother. So from this point, there is a variety of things you could do. You could say that the geometry is finished now, so you can go off and start working on the texturing process. Or perhaps you didn't want any curvature, so you could just delete the lattice and have the whole roof being straight. Or perhaps you want to cut into this roof to make corners, and that is what I'm now going to show you. So for everything to be perfectly modular, we need to adhere to one rule. This roof needs to be cut at a 45-degree angle, so that it can perfectly fit with duplicated versions of it to form a complete roof. And you will see why that is important later. Also, before we move on, now will be a good time to apply our lattice modifier, if you are happy with the changes. Just avoid deleting the lattice, just in case you want to use it again in the future. So we can just keep our lattice hidden for now. So let's begin. Let's set the origin of our roof to the center of mass surface again. And then Shift and S, cursor to active. Now create a plane. Scale it up so that we can sit properly. And let's just move it up as well. And the first thing to note, do not scale this plane on any specific axis. Only scale it uniformly. This plane must be a uniform square at all times, where each of its measurements match. This will help us adhere to that 45-degree rule. Right, so now let's go into edit mode on the plane, face select mode, and now let's right click on the top face and select poke faces. So this has now given us 4 45-degree angle cuts on our plane here. Let's delete the bottom part here, and let's take these faces and let's just extrude them up. And let's also come to the object properties here, viewport display, and let's just display our new shape here as wire, just so we can see through it. And now let's scale the shape around so that it fits around our roof, but also make sure that there is a slight gap down here. So something like that. Just want a bit of a gap there. And again, scale uniformly. These measurements need to match. Let's also take our shape and just make sure that it is moved down into the roof. Like that. And now with the roof selected, create a Boolean modifier and assign the new shape we made as the object for the Boolean. And if you're happy with the cut, just apply our Boolean modifier. So what have we just done? Well, we've basically used our new shape to cut into the geometry of our roof here. And we are using a 45-degree cut, which means that if we were to duplicate this roof and rotate it on a 90-degree angle, it should match up quite nicely. But before we do that, let's just set the transform pivot point up here to 3D cursor. And now select the Boolean box and set the origin to geometry. And then Shift and S, cursor to active. And now, in top of a graphic view, just so you can see it a bit better, if I was to duplicate this roof with Control C and Control V and then rotate on the Z axis by 90 degrees, you can see that it's lined up quite nicely. If you zoom in, you may notice there's still a slight bit of a mismatch. Normally, but this is because of the lattice modifier. If you didn't use a lattice and any curvature, then this would line up perfectly. These mismatches aren't really an issue for a lot of Asian roof architecture, because with a lot of the architecture, especially Japanese architecture, you normally have a seam or another shape that runs down here alongside the seam, so this would get covered up. So let's now duplicate our roof another 2 times to complete the shape. And I'm just going to hide the Boolean box here. So just to give you an example of what I mean by covering these seams, if I was to just create a cube, for example, make sure to change the pivot point back to bounding box. I can scale this up, rotate on the Z axis, type 45 to put on a 45-degree angle. And let's just bring this up a bit more on the local axis. By the way, you don't have to copy what I'm doing. This is just to give you an example. Extrude that down. And then bring that down just like that. Let's bring this down. I'm just going to use proportional editing. Yeah, it's not a great example, but this is what I mean by you normally get shapes that cover up the seams with a lot of Japanese architecture. And if I was just to come back to 3D cursor on the transform pivot point, Control C, Control V, rotate 90 degrees, rotate 90 degrees, rotate 90 degrees. You can even add a cube in the middle here. That's just an example of what you can do. And as you can see, the seams are completely cut off. They are not visible. And then in terms of materials and UV mapping, that isn't too hard to do. All of these shapes should already have some decent UVs, at least for a basic material. For example, if I was just create 2 materials, and again, you don't have to follow what I'm doing here, this is just an example. But if I just create a material called roof, a material called caps, something like that. And then I'm just going to use some materials I downloaded off Substance Source. And I'm also going to use a Node Wrangler add-on for Blender to get these textures into Blender a bit faster. So with the roof, shading, I'm going to do, I think it's Control Shift and T with the Node Wrangler add-on. Let's select clay. And there you go, you can see the material applying now quite nicely. And then what I'm going to do just quickly is come into Material Preview, and we're going to just assign these circular caps at the end here to our caps material. And then back into shading, caps, Control Shift T. So I'm just using a sewer plate material, which I don't advise you do. It's quite a weird material to use for a Japanese temple, but it's close enough to what I want. You may also need to do some UV unwrapping here. So if we come into UV editing, this is actually quite easy to do for a lot of similar shapes like this. With them selected, you can just do U and reset. And then you've just got all of them as a similar shape. And there you go. You may also want to do the same thing with these caps here. Again, a little bit tedious, but you could actually just do a vertex group for this as well, which would speed up your workflow. But again, I'm just doing this for a showcase mainly. Apply the caps. U reset. It looks a bit strange, but you get the point anyway. So then what you can do is we can just delete these other roofs, and then we can take our roof here and then do the same trick again. And let's give our other shapes here the same material as the roof, why not? And just a quick trick, if you come and select your roof, select the roof material here, and then hold down the Alt button and left click drag from this material icon here and just drag it on to our shapes here. If you watch my Blender tutorial series, then you may know that already. And then I can just grab these and then just do like a cube projection unwrap. Anyway, I went off on a tangent there. So that's basically, you know, an example of the kind of results you can get. One other thing we need to fix, which is really, really quick. If you zoom in, you will see that the geometry is still a bit harsh. You can see the lines here because it's still using a flat shading method. If you click the roof, in fact, click all the roofs and do shade smooth, there we go. And then zoom in, those lines disappear. And you remember when I said to mark the edges as sharp? Well, the reason for that is so that the shading works better on the edges. Because if we didn't do this, you would have had some pretty strange results from the shade smooth function. And yeah, that's basically it. Japanese Kawara Roof. Do what you want with it. Put it into a game, a film, a render, whatever you want. And you can also adjust the geometry. You can change around the materials. Again, material creation is another topic of its own, and it would require us leaving Blender, which is why I didn't go through it on this video, as this video is solely about Blender, roof workflow, and just the tiling geometry. But I will do a separate tutorial series on that in the future, and then you can apply that knowledge to any 3D model you like. There are also plenty of textures online if you want to use them on your roof model. So in summary, we have learnt how to construct a Kawara roof, but more importantly, we have worked through a solid workflow on creating any type of roof really. With the process we have gone through, you can use that to create Roman roofs, Korean, Chinese architecture, and even fancy styled roofs actually. Like, I don't know, elven roofs. You can make something from Lord of the Rings, who knows. I hope this video has helped you, not just understand roof building in Blender, but has also armed you with a bit of knowledge of the tools that Blender offers so that you can apply it to your other designs. And I always hate saying this part, but if you enjoyed the video and if you would like to see more content like this, feel free to subscribe. I'm also on Instagram. I will link that in the description. And I have a lot of planned for the near future for YouTube and other things, so definitely stay tuned for that. Anyway, thank you for listening, and I will see you in the next video.